Alright, tonight's video looks at length and mass. Alright, these are two important things that we'll be learning how to measure in our measurement section of this unit. So we're going to start with these two. We'll move on to volume, density, and temperature throughout the week. But let's start with length and mass, two pretty straightforward topics. So we'll start with length. Alright, the basic unit of length, as we've already talked about, is the meter, as represented by lowercase m. Alright, so you guys are going to take own notes for this section. Alright, we're starting off taking our own notes tonight. So the basic unit of length is the meter. It's represented by lowercase m. Technically, the standard, you do not need to know this, is the distance traveled by light in a vacuum in 1/299 million whatever of a second. Yeah, that's the standard. It's also the length of a meter stick. So important metric units you should know, though, are some of these quick and easy conversions. All right, you could figure all this out by doing the conversions like we practiced last week, but it's good to memorize these three really basic conversions that we're going to use. These are the measurements that we're going to use the most, so it's good to be able to in your head quickly be like, oh, a kilometer, that's 1,000 meters. A meter, 100 centimeters. A meter is also 1,000 millimeters. So to know those is a good thing. Right, and so if we look at that, a meter or 105 centimeters, right, a meter is only 100 centimeters, so this is larger. 4 kilometers would be 4,000 meters, so this one's going to be bigger. 12 centimeters is going to be 120 millimeters, so it's going to be bigger than that. 1,200 millimeters, right, a meter is only 1,000 millimeters, so this is going to be our bigger value. So how to measure length, right? Measuring length, we're going to use a ruler. All right, so measuring length. All right, and keep taking your notes. All right, measuring length, we're going to use a ruler. We're going to line the ruler up with the end of our object, make sure the 0 lines up with the end of the object, and we're going to see how far the object goes along our ruler. So on most rulers that we'll use, the centimeters will be labeled. So it'll say 0 and it'll have a little cm on there. All right, the big markings are centimeters. The little markings are millimeters. So looking at this line, the length of this line in centimeters going from the 0, we see that it's 2. All right, it helps to know that these little in-between lines are every 5. So 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8 centimeters would be the length of the line in centimeters. All right. In millimeters, though, right, a centimeter is 10 millimeters, right? And I'm basically just doing a metric conversion, going from centi to milli, one space to the right. It would be 28 millimeters. These measurements mean the exact same thing. The length to the nearest centimeter, right, I'm going to round, would be 3. All right, you don't need to write these numbers in your notes from the example because you don't have the picture there. But we do need to know for measuring length, we use the ruler, we line it up with the 0, we see how far it goes. The numbers usually represent centimeters. All right, measuring length with multiple units. What if I have a measurement of 5 meters, 62 centimeters, and 3 millimeters as one measurement? So multiple units. All right. If we have a measurement in multiple units, the first thing we need to do is convert all measurements to the same unit. Okay, so in this case, I want to convert everything to meters using my normal King Henry died by drinking chocolate milk conversion, and then we can add all the measurements together. All right, all of these are measurements of length, 5 meters, 62 centimeters, 3 millimeters. I convert each to meters, and then I add them up. And then I get 5.623 meters is going to be my measurement there. So that's length. Let's talk about mass quickly. All right, so mass is different than weight. Those are two different things. So mass is the amount of matter in an object. It's literally the amount of stuff, kind of a measure of the particles in an object. Weight is different. Weight refers to the force of gravity on an object. And so for weight, it's going to depend on mass and the strength of gravity. Right? On Earth, gravity is the same everywhere, so we can kind of use these terms interchangeably. But in outer space or on other planets, there is different amounts of gravity. So your mass would stay the same, the amount of matter in you doesn't change, but your weight would change because the force of gravity would change. All right, our basic unit is the gram, represented by G. All right, and some key units to know. So basic unit is the gram. All right, and some key conversions. 1 kilogram is equal to 1,000 grams. And another important one is that 1 gram is equal to 1,000 milligrams. All right, these are kind of the most common units we'll use in mass: kilograms, grams, milligrams. We don't really use centigrams or hectograms that much. So just knowing these conversions, again, will help you do stuff quickly without having to go through your King Henry chart. But you can always use that. It's always going to work. So again, 1 kilogram, 1,500 grams. That's 1,000 grams. That's 1,500. That's bigger. 1,200 milligrams. That's only 1,000 grams. That's bigger. 12 milligrams or 12 kilograms. All right, same number, but a kilogram is a much bigger unit. Obviously, that's the larger number. 4 kilograms would be 4,000 grams. So 4,500 grams is our bigger number. So to measure mass on our triple beam balance, all right, let's get down here. Too far. Measuring mass. All right, and we're going to practice this in class. It seems a little tricky when you explain it over the computer, but it's really not that hard. All right, we use the triple beam balance. All right, we're going to put our object on the pan, and we're going to slide the weights until the balance, until the lines on the end of the balance match up. So we have 3 separate things that we can move. We'll start with the biggest one, move it until we are far enough, then we'll start with the next one, and then the last one. Now, the back 2 sliders, back 2 weights, must be locked into a groove. All right, there are little notches that you'll see when we practice this in class. Those back 2 weights have to get notched into a groove, otherwise you won't be able to get a reading. All right, once you do that, you simply add the amounts on all weights to find mass. So let's give you an example. Say I put an object on the balance off to the left, and I slid these around, and this is when it balanced. All right, we just add up the amounts on each. They're all in grams. So this one would be, right here we've got 300 grams from this mass. We've got 70 grams from here. And we've got what looks like 3.1, 3.2, about 3.3. It's kind of in the middle. I'm going to call it 3.3, which gives me a total of 373.3 grams. All right, so make sure you write a summary on your notes, and I will see you in class on Monday to practice measuring length and mass of various objects.